Hello, my name is Jeff Heaton. In this video segment, I am going to show you the Hopfield neural network. The Hopfield neural network is a simple neural network type invented by Dr. John Hopfield in 1982. The Hopfield neural network consists of a single layer. This layer contains one or more fully connected neurons. Fully connected neurons are generally called recurrent neurons. You can also have feed-forward neurons. We will see these in a later video segment. Here you can see a recurrent neuron. Notice that this neuron is connected to itself in addition to the next layer. In a recurrent neural network, usually every neuron on a layer is connected to other neurons on that same layer. Compare this to a feed-forward neural network like you see here. Here, each neuron in the layer is connected just to the next layer. These are two of the most common types of neural networks in use today. However, the Hopfield neural network is a recurrent neural network. Here you can see a Hopfield neural network with 4 neurons. It's fully connected. This is a single layer neural network. Hopfield neural networks are designed to take binary input. That means the input, which you see on the left side of the Hopfield neural network, is 0 or 1. The output, which you see on the right side of the Hopfield neural network, is also 0 or 1. So you're presenting a pattern, which is a binary number, and expecting an output from the Hopfield neural network, which is another binary number, which is a series of zeros and ones. While binary numbers are convenient for computers, most neural networks are not typically designed to accept zeros and ones directly. These zeros and ones need to be transformed into the numeric range that a neural network generally accepts. Most neural networks accept numbers between negative infinity and positive infinity, very often constrained to just -1 to +1. We need to convert the binary numbers into this range. Usually this is done using bipolar numbers. Bipolar numbers have 2 values, usually a negative value and a positive value. Converting between binary and bipolar is very easy. Binary 0 or false becomes -1 bipolar. Binary 1 or true becomes +1 bipolar. Now I will show you how to actually create a Hopfield neural network. To do this, we're going to use the Incog workbench. The Incog workbench is a tool that allows you to graphically construct neural networks and then produce Java source code, C# source code, or even Visual Basic source code based on the neural network that you just created. The Incog workbench is the graphical part of the Incog Neural Network and Bot Programming API. Incog can be accessed from the URL that you see here on your screen. We will now begin the demonstration of creating a Hopfield neural network using Incog. We begin by creating an object. We're going to create training data as well as create a neural network. When you create objects in Incog, they're set up for just simple default neural networks. Usually you will have to go into these objects and customize them for what you want. We will do this now with the training data. Ideal is only used when you have a supervised neural network. The Hopfield neural network is unsupervised. You're not giving it any sort of expected output. You're just giving it patterns, and you want it to recognize those patterns. So we're going to get rid of the ideal column by selecting one of the cells in it, like I just did, and I am going to delete the column. Now we just have input 1 and input 2. We're going to add 2 more columns. We want to add input columns. We're now up to 4 input columns, which is what we want. However, there's 4 rows as well. We don't want 4 rows. You use rows when you want to have multiple patterns that you're training the neural network for. So we're going to select these rows and delete them so that there's only 1 remaining. Now we've got just 1 row. We're going to edit this row and put in a pattern similar to what we had before. We've now created a training array that is going to be used with just one input pattern. We're now done with the training data. So we can close the training data. You can see the training data there on the Incog file browser. Notice the ideal size is 0, input size is 4. This is what we just edited. Next, we're going to edit the neural network. The neural network that you see here is set up for a 3-layer feed-forward neural network. We don't want to do a feed-forward neural network. We want to do a Hopfield neural network. So we're going to delete everything. We're going to choose Hopfield. Now, as you recall from earlier, a Hopfield neural network is a single-layer neural network. So we're going to have just the one layer, and that's it. I'm going to go ahead and double-click this layer so that I can edit it. I do want to change the neuron count. We want more than just 2 neurons. We want 4. That allows it to match the training data that we just provided. We now have a neural network. However, the neural network is not yet trained. I'm going to go ahead and close the neural network. We now have the training data and the neural network data. To train it, we click Train and then Train Hopfield layers. This will train any Hopfield layers in the neural network. Here you input the data. We're going to have the training data be data 1, which is this training set that we just provided, and the network be neural 1. Maximum error really does not matter too much for a Hopfield neural network. Leaving it at the default is fine. We're going to click OK. A Hopfield neural network trains very rapidly compared to the other neural network types. A window pops up that says that training is now complete. We just click OK. Now we're going to test the neural network. We can go ahead and close it. Right-click on the neural network and choose Query. This brings up the query window. We're going to enter exactly the same pattern that we trained it with. Then you click Calculate. This will update the output row. There you can see the output is the same as the input. This is the auto-associative property of the Hopfield neural network. The Incog workbench is usually only used to create the initial setup of the neural networks. Then you generate code and incorporate those neural networks into more complex applications. Here we see a more complex application of a Hopfield neural network. It still uses all exactly the same principles of a Hopfield neural network. It is a single layer of fully connected neurons. However, this application shows the input to the Hopfield neural network as a 8x8 or 64-celled input pattern. The Hopfield neural network for this one has 64 neurons that correspond to each of these cells. We're going to see how we can train it to recognize 2 patterns. I'm going to begin by drawing a pattern in the upper right-hand corner. You can see it's a simple square. I'm going to now go ahead and train the network for that pattern. If I clear it, I can basically start to paint part of the pattern, and if I click Go, you'll see that it recognizes it as that pattern. The problem is it would recognize just about anything as that pattern. If you draw something over here and you click Go, it sees it as that other pattern. That's because it only knows one pattern. Let's teach it a second pattern. We're going to draw in another square down here, and we're going to click Train again. Now it's trained for 2 patterns. Let's draw part of a pattern and see if it recognizes it. We'll click Go. You can see it recognized that pattern. It fills in what is missing. It can distinguish it from the other pattern, as you see here. Hopfield neural networks are generally used for simple pattern recognition, such as this, or even more complex applications than this. This video segment introduced one concept in neural network programming. If you would like to learn more about neural network programming, you may be interested in our books, Introduction to Neural Networks for Java, or Introduction to Neural Networks for C#. Both of these books contain many examples and teach the fundamentals of neural network programming.